Hi, my name is Erick Engelke from the Faculty of Engineering at the University of Waterloo. I'm the Director of Engineering Computing. Today I'll talk about web and mobile applications. In this presentation, we'll talk about reasons for development, the state of the market and what users can expect or do expect, the state of modern development environments such as IDEs and tools that you use, and the solutions that I now use. Useful takeaways for everyone and a few example applications will be shown. We do development to solve an existing problem. It improves client services, reduces workloads or improves efficiency of our staff, and it secures data on servers rather than letting them store it on post-it notes, spreadsheets, and paper lost in desks. And usually our solutions solve several of the above problems. Typically we'll have a client web page or application that users run, and a server that communicates to the client to enforce the business rules and security. Data will be stored on SQL or NoSQL databases, and we use n-tier databases for information about students, financial account numbers, etc. There'll be a large repository of data, pictures, CAD drawings, blobs, or other discrete objects. Enterprise applications are ones that have scalable performance from 100 users to 100,000 or more. They're n-tier database capable, and caching is used throughout for performance improvements. They'll be multi-platform by using SOA or SOA, service-oriented architecture. And their web accessible interface will be available so that users don't need to download a physical client, a PC client. They're inherently secure, supporting externalized authentication through whatever method you need, and authorization will be enforced so that people can't change things they're not allowed to. They'll be based on principles of least privilege. They'll have auditing built in and prepared SQL statements, not freeform. If you're developing a new application in 2017, the web is essential. Fat clients are increasingly replaced by the web. Multi-platform and multi-vendor solutions are done automatically by the web. It's operating system version agnostic. You can upgrade to OS without acquiring a new client. And there's no client installation, which eases the use by users. And there's ease of upgrades. You just create a cutover time and then you update the web version. And also it might be possibly mobile capable. Mobile web is essential too because mobile traffic is now outpacing regular PC traffic. Know your target. Web pages that are not designed for mobile are usually poor at mobile. Who is your target? Are you mobile first, simply mobile capable, or mobile tolerable, where it can be used on a mobile device but with some difficulty? The commonality among web clients has been dictated by the whole of the market, not by any one player. Flash, Silverlight, client-side Java, and ActiveX are all out. They were sold as technologies to be used, but they just were not bought by the market. HTML5, JavaScript, and Ajax are the winners. HTML5 progress has been excellent as most browsers now do updates to get the latest versions and the more support. We still have some implementation differences, such as Internet Explorer implements Ajax differently than the WebKit-based ones, and Safari is missing some useful HTML5. Toolkits can hide most of the difference, and they're always getting better. People now expect to use applications that look like Facebook, Google Search, Gmail, YouTube, LinkedIn, and eBay. They have universal compatibility with clients because they work on every browser. There's a single rich page web application with JavaScript doing Ajax updates, which is faster than server-generated HTML. It feels like a local application. Some updates are asynchronous, some you have to wait for, and it scales better than server-generated HTML, which can be very slow. They use two-way communication using WebSockets. Users now expect applications to look like this. They expect JavaScript applications. JavaScript in the wild in 2016 is an object language. It's not really a class language. It's also known as ECMAScript and is standardized, but it's a rolling standard. People are running version 3 in the field and up. Increasingly, JavaScript is becoming the universal assembly language of the web. It works, it's not pretty, and it's a pain to debug, but other strategies can be built on it, and it's mostly securable, unlike Java in the client. JavaScript 1.0 was written in 3 weeks, and it's suitable for maybe 100 or 1,000 lines of code, but not anything beyond that. There's a lack of strong typing that makes it more error prone. There's a lack of pre-processing, so you have more runtime errors, but it does allow dynamic coding and loadable modules. There have been wonderful libraries and extensions added to JavaScript, such as jQuery and AngularJS, Google Graphs, and various other tools. There's many open source and commercial libraries available, and you can use Cordova to create native apps with JavaScript. Client languages such as Node.js are also available on servers. It's easier to write when you're not switching between two very different languages on your client and your server. Increasingly, JavaScript is being used as the machine code for other languages. Google Closure compiles JavaScript to better JavaScript. It parses, analyzes, and links in only the needed code and rewrites it. And it has compile time syntax checks rather than relying on runtime errors. CoffeeScript, Ruby.js, Java, and C++ and TypeScript all have language that compile to JavaScript. I've used the C compiling using LLVM to port some libraries from C to JavaScript. I'd say if you're starting a project in 2017, I would recommend using a shared language between the client and the server. It's less confusing. Use of powerful languages. I try not to base it on C because buffer overflows and strings are still a pain in C. Better languages are like Ruby, Java, C++, etc. Use a good mature client with a user interface, database, and other libraries and object-oriented. Have good mature server libraries. Compatibility with all JavaScript extension libraries is important, and compatibility with all server extensions is important too. Use multiple server platforms, or at least have them available. Some of your clients want to run on Windows, some want to run on Unix. Use unit testing and regression testing, and it should have OpenID compatibility. There are several fine choices which meet all these criteria. I chose Object Pascal. It's similar to C, but slightly different. Its compiled code is as fast and small as C, and it's faster than Java or PHP on the server, and at least as fast as JavaScript on the client. It has real strings and no uncaught buffer overflows. It's simpler than C++ or Java due to single inheritance model. It's powerful. I've used it to write device drivers, GUI applications, mobile applications, etc. And it's standardized. It doesn't have any of this long string nonsense that comes into C and C++ for Windows. And yet the code is very multi-platform. Object Pascal has been around for 20 years, and unlike PHP, it doesn't keep changing. It's a highly typed language. The compiler finds most of your errors, not the user, such as JavaScript and PHP, where we often get runtime errors. It's a single pass language. It means compilation speed is phenomenal. Here we see a web application in use inside the IDE. If you enter a number here, such as 1 degree Celsius, it shows the Fahrenheit temperature. As you update the number, it automatically updates the Fahrenheit temperature. People expect this now, that our web applications run in real time. If I just click the exit button, it goes to the IDE showing what the application looks like. You can move things around. You can drop in other things such as balloon text box, which is here, no here. And you can change what words appear in here. It's all trivial to do. The code for this mighty application is just a couple lines of Pascal. To run it, just hit F9. And there it shows with our new extensions. On the server, I use either Free Pascal or Delphi. I've used both. The server can be any modern operating system, including Linux, Windows, OS X, or even a Raspberry Pi if you want. I use an open source object relations manager called mORMot, which is also middleware. It works with all major databases from Oracle, Microsoft SQL, MySQL, Postgres, Mongo, and others. There's automatic transaction and parameter logging. It's fast, simple, and secure. Its standard-based SOA uses runtime type interface to marshal the data automatically between the client and the server. It includes PDF writing and WebSockets. There's a book that's going to be available for it called Enterprise Databases, which I wrote, which will be released in 2016. On the client, there are two brands available, Elevate Web Builder and Smart Mobile Studio. I tried both. I liked Elevate Web Builder better. It's purely a personal choice. And I wrote a book or two about EWB, and it's what I'll describe for the rest of this talk. Both the products have command line compilers and all totally graphic IDEs. Both have OOP, object-oriented, and responsive graphics design. Both can compile to HTML and JavaScript. Both are low-cost commercial products with unrestricted distribution licenses on the compiled code. Elevate Web Builder is designed for single web page applications with HTML and JavaScript, like Facebook and Google Mail. Developer program is entirely readable in Object Pascal. It compiles to efficient JavaScript, either purely translated or compressed. It can call almost any JavaScript library right from Pascal, so it can do anything JavaScript can. It links in only needed functions for a reasonable size, and it grows very slowly. Language is highly typed. The compiler leaves no ambiguity, no late binding, and it's documented in these two books. The code that you use is very small and readable. For example, this application is only 3 lines of code. Elevate Web Builder converts it into the following JavaScript code, which you can see is a little bit more difficult to read. And if you click the optimize, it compresses the JavaScript so it's barely readable but still functional. This obfuscates the code somewhat. Object-oriented libraries require only a small fraction of the code of typical JavaScript, so there's less code and less errors. More common controls are already available, tested, and included. You can use Elevate Web Builder's IDE to lay out the controls. It's a drag and drop environment, and I'll demonstrate that shortly. There's responsive design or static layout, so you can have your web page grow as needed for desktop or shrink as needed for mobile. HTML5 automations are quite easy. It's built on technology and the user interface model that Delphi and Lazarus have had for more than 20 years of proven success. All the products that I use work in UTF-8, which means that character sets are supported from Chinese to Russian to anything European. Includes quote and apostrophe, so you can have like O'Brien names and handle gracefully. You don't have to check for the apostrophes. And my environments use prepared statements. There's no worried about people passing parameters that can break your environment. In my environment, using passwords are never transmitted in clear or even in TLS. We use public key cryptography to encrypt the passwords to transmit to the server. And even scanning the browser cache or man-in-the-middle attacks do not reveal the password. It offers some safety beyond mere TLS. Why? Because all versions of TLS to date and SSL to date have been broken. Today's TLS is next, so we want to be prepared. The cost of the environment depends what you want to use. Open source can lower your entry cost, but may mean slower startup, so I recommend using books with them. Commercial tools may have free or flat or per user licensing costs. Consider licensing costs of database, operating system, and middleware and runtimes. Will they limit who can connect? Will they limit who your audience is? If you use open source, support it by helping or buying support when you depend on it. I use mORMot and GNU Pascal on server that supports Windows, Linux, and Microsoft. And also Win32, yeah. Delphi Pro costs about $1,000 a year. You don't need it. You can use GNU Pascal if you want. Environment Web Builder offers free runtimes. It's about $300, I think, on startup and $300 a year for developer access. The third-party toolkits are available. You have to look at the licensing yourself. My general advice is don't make a web client as a second-class citizen unless it's mobile. For example, if you try and use Outlook Web Access, you'll find that it's not as usable as the Outlook Outlook standard client. You can't do everything. I don't think that's appropriate. Don't code directly for one browser or one phone or one database, and use libraries whenever possible because many are mature and well tested. Use unit and regression testing. Find a good book on the subject. It'll shave weeks to months off the learning time. If you have problems, make sure you have all the latest compatible releases of everything. For specific coding advice, I say don't code in JavaScript directly. Use the languages that are better and available for much less code and fewer errors. Use a language or environment that checks types, bindings. Many of them do. Use a system with a GUI builder. There are many of them. New environment, have a throwaway project or be prepared to redo it when you're experienced. Remember to separate your business logic from your user interface code. It's a beginner's rule. Have well thought out server calls and be prepared to rewrite them during development. Use prepared statements or an ORM with your database. Do not use freeform SQL. These are the sources of things that I used. You can pause in the slides if you want to link to them. Here's some apps I wrote with Elevate Web Builder. I'll demonstrate them in a second. Surveyor, which is my first project, was used by profs instead of clickers. It's used by our dean's office to do comprehensive debt load survey with 7,000 clients. It's possible to create and take surveys on any web browser, including phones. We're told that people will be using mass transit, so I made it so you could even create a survey on a phone on your way to work. It's actually a phone-centric design. We made design look the same on phone as well as web browser because we didn't want there to be any inherent differences in what people see. User interface designed for the phone real estate and for cellular data, busy Wi-Fi. It uses the network very sparingly. Also, it's designed for rebooting hardware lost signals. You can pick up where you left off in the survey at some later time. It outputs to a spreadsheet or to on-screen display for the survey taker. This is what Surveyor looks like. The person logs in with their user ID and password from the Active Directory, and they're presented with some introductory stuff and then some questions. They can select a simple answer in this case. In this case, it's multiple choice answers. There's a slight delay between each page as it saves to the network. Just a small JSON save. Another application I wrote is a schedule program which allows people to book 15-minute appointments with their advisors in Microsoft Exchange Calendar. You can come into it using the web or mobile or a QR code on the door or a content management system link. It has responsive design, so it's nice in phones. It's designed for easy finger or thumb navigation in the phones, and the server end was done in PHP, which interfaces with Microsoft Exchange, our Active Directory, and our database for student information. Here's what the schedule program looks like when you load the application on the web. You log in again with your user ID and password, and it presents a view of this week, or if you press the button the next week, it tells you that it's going to send your user ID and student information to whomever you're booking your appointment with. It shows the calendar here for the second week, and we pick a time that says not busy. It asks if we want to confirm. It saves to the calendar. That takes a second, or two, or three. And then it informs you that the appointment has been booked. If you're in a limited browser size, such as on the phone, it moves the columns around to fit them onto the screen. Took is another application I wrote. For more than 10 years, Took has been the software distribution tool for the Faculty of Engineering to more than 2,500 workstations, meaning 300 or more packages of software. It starts to deploy in under a minute. It's compatible with Microsoft SCCM packages, but offers an extra layer of security for reduced risk. Uses digital signatures to restrict package installation to trusted individuals. Even if you can crack into the system, you can't force your buggy applications onto others. Distributed management, we have 8 departments in engineering, so it had to offer granular management. And I totally redid it this year in Elevate Web Builder. After you log in, you're presented with a menu of operations you can do. Here we'll search for a computer such as Maggot Star, which shows all Maggot computers. You can drill down into any particular field and look at the results. You can sort by clicking on the top column. You can select checkboxes to select the things to use and then an operation to perform on them. It can handle many thousands of items in your lists. Here we're looking at hundreds of groups of computers. If you drill down into them, you see all the computers in that group. It has report writing to the screen. And I think you kind of get the idea. You can do basically anything you want to with this environment. You can create any sort of complex application. Thank you for watching my presentation. Please feel free to leave feedback below.